Hello and welcome to Science Video Quiz. My name is Professor Science, and today we're going to discuss atoms. No, not the student named Adam in your class, but A-T-O-M-S, atoms. The stuff that makes up everything. After you've learned all about atoms, some of my friends will quiz you on, you guessed it, atoms. But first, let's refresh your memory on the matter of atoms. Get it? The matter of atoms? Well, if you didn't get it now, you'll get it in a minute. Everything in the world is made of matter. You, your desk, the air, everything is made of matter. But what is matter made of? Matter is made of atoms. The atom is the basic unit of matter that forms everything. An atom is the smallest amount of material you can have that will retain all of its original characteristics and properties. Here's what I mean. If you took a block of gold and cut it into the smallest piece possible that still holds the properties of gold, that would be an atom of gold. Because this piece of gold is as small as you can get it, it is indivisible or not able to be divided. You wouldn't be able to see this piece of gold with your naked eye. An atom can only be seen with the use of a microscope. Not just any microscope, but a highly specialized one called an electron microscope. These microscopes were recently invented, but the road to atomic knowledge was under construction many years ago. Over 2,000 years ago, long before any microscope was ever invented, a Greek philosopher known as Democritus first speculated that these small pieces of matter existed. He called them atomos, which is Greek for indivisible, thus our word atom. Because Democritus and his fellow philosophers believed and taught their idea of the atom, they were called atomists. They spent a lot of time contemplating the atom and thought that there were many different kinds of atoms that were of different sizes and shapes. Despite the atomists' early insight, no substantial developments in atomic theory were made until the early 1800s. While studying the science of weather and gases, an English chemist named John Dalton found that tiny particles, or atoms, were influencing his experimental data. In 1803, he proposed the first modern atomic theory. First, Dalton stated that all elements are composed of atoms that are indivisible. Second, atoms of the same element are exactly the same in structure. Third, atoms of different elements have different structures. And finally, atoms of two or more different elements join together to create a compound. Dalton's first modern atomic theory has provided the basis of modern chemistry and created a foundation for the current atomic theory. In 1897, J.J. Thomson discovered negatively charged particles existing in gases known to be electrically neutral. Thus, he claimed a particle smaller than the atom must exist within the atom. Thomson named the negatively charged particles corpuscles. Today, we call them electrons. The discovery of negatively charged particles in a neutral gas led Thomson to reason that positively charged particles must also exist to balance out the negative charge. He then proposed an atomic model with random placements of positive and negative particles, which came to be known as the plum pudding model. A few years later, while shooting positively charged particles through a thin piece of gold foil, Ernest Rutherford concluded that the positively charged particles of an atom existed not randomly throughout the atom, as Thomson proposed, but in a relatively small area in the center of the atom called the nucleus. He found most positively charged particles passed through the atoms of the gold sheet without any problem, leading him to believe that most of the atom was empty space. Rutherford and his 1908 gold foil experiment created a working model that eventually led to the Bohr model. In 1913, Niels Bohr, a Danish scientist, asked the question, where exactly in the atom are the negatively charged particles? He proposed that the electrons circled the nucleus on tracks, similar to the way planets orbit the sun. The tracks are called energy levels. These energy levels help us to understand how atoms of certain elements tend to come together to form compounds. Eventually, Bohr's model gave way to the current wave model. Thanks to some complicated mathematical equations called wave mechanics, scientists were able to construct a more accurate atomic model. In this wave model, electron movement appears to be more like a vibration within an electron cloud than a circular orbit. The image shown here is not to scale, but gives the general arrangement of the atom and its particles. In reality, a nucleus, in relation to the area of its electron cloud, can be compared to a bee in a football field. Well, that was quite a history lesson. But I thought we were studying science today. Hang out with some of my friends and answer their questions while I prepare a science lesson for you. See you in a few.
That Professor Science, he's a smart guy. I bet he could handle the curves of this racetrack really well. Let's see if he can handle this curve coming up. When did humans first start theorizing about the atom? A, during the last 200 years, B, about 400 years ago, C, about 5 minutes ago, or D, over 2,000 years ago? How did you do? It seems like you handled that like old pros. Write down your answer now.
Well, I'll take a break from plate twirling to ask you this one. True or false? An atom can be divided into a smaller piece that still retains the element's original characteristics. All right, no confusion for you. Write down your answer for later, and let's try on the next one.
Welcome all you science lovers to DJ Ricky Wave's Science Show on the one and only KVQZ. I'm bringing you all the top science sounds you want to hear. DJ Ricky never lets a listener down. Check out this sound. True or false? Air is made of atoms. All right, that was smooth. Now you've heard the latest. Write down your answer and stay tuned for the next hit question.
Wow, we are moving through the stars quickly now. It must be almost showtime. Some big names have been through here like Kelly Cluster and Carl Kinetic. We better get inside. I think the show is about to begin. Who proposed the first modern atomic theory based on laboratory observations in the early 1800s? A. Ernest Rutherford. B. J.J. Thomson. C. John Dalton. D. Abraham Lincoln.
Will you look at that one?
Wow, that question was amazing! Stay tuned and we will bring you more great questions.
Phew! A couple thousand years of materializing here and there puts quite a toll on your molecular structure. Back to atomic history. Here's the next one. Which of the following was not included in Dalton's atomic model? A. Electrons travel in energy levels. B. All elements are composed of atoms that are indivisible. C. Atoms of different elements have different structures. Or D. Atoms of the same element have the same structure. Well, how did you do? I bet you didn't need to use any wishes to get this right. Now don't forget to write down your answer. Bye!
Well, howdy, y'all. I thought I'd see if you could wrangle up the correct answer to this question for me. J.J. Thomson proposed an early atomic model in which the placement of charged particles is random. We sometimes refer to this model as A, the Ford model, B, the plum pudding model, C, the modern atomic model, or D, the Rutherford's model. All right, partners, round your answer there. Settle into your saddle now. There are more questions on their way.
Okay, team, stay focused and keep your eye on the question. Don't let it try to fool you. Here we go. Which scientist is credited with discovering the nucleus of the atom through his gold foil experiment? A. John Dalton, B. J.J. Thomson, C. Albert Einstein, or D. Ernest Rutherford? Way to go, team! Log your answer now, and let's get prepared for our next challenge.
Oh, hi! We're having a bit of a problem out here today with our pod. A meteor hit it and we need to fix it. I need to get there immediately. Who is the Danish scientist that proposed electrons orbit around the nucleus like planets around the sun? A. Democritus, B. Niels Bohr, C. Albert Einstein, or D. Ernest Rutherford? Whew, that specimen wasn't as bad as I thought. You guys were pretty brave. Now write down your answer.
Hello, this is Quisitor. I have been programmed to test your knowledge. My creators thought you might appreciate this coming from a computer. What is the current atomic model called? A. The wave model. B. The plum pudding model. C. The atomic model. D. The Bohr model. Are you done? Did you write your answer down? Good. That is all.
Ahoy, science sailors! Last question for this round. Then we'll sail on over to Professor Science. Which association most accurately describes the size of the nucleus in relation to its electron orbit? A. A penny inside a gallon jar. B. A drop of water in the middle of the Grand Canyon. C. A bee inside a football stadium. Or D. A slice of pickle inside a hamburger bun.
Ah, that's a good one.
Ooh, write down your answer to help stabilize this boat. I'd hate to tip over. Professor Science to our stern.
Oh, wow, you were awesome! There are so many scientists that contributed to our current atomic model, and you knew all of them. Now let's take a closer look at that atom. If an atom is the smallest piece of any element, what do you suppose an atom is made of? As you can see here, the atoms are made up of three main subatomic particles. There's the protons, neutrons, and electrons. The protons and neutrons are packed together in the center of the atom called the nucleus. And the electrons orbit around the nucleus, forming an electron cloud. Subatomic particles are so tiny, we measure them by atomic mass units, or AMUs. Each proton and neutron have an atomic mass unit equal to 1 unit, but the atomic mass of each electron is extremely small, 1/1836th of an atomic unit. Although electrons have relatively no mass compared to protons and neutrons, electrons do have a negative charge equal to 1, and protons have a positive charge equal to 1. Neutrons are, you guessed it, neutral. So atoms with equal numbers of protons and electrons are electrically neutral because their charges cancel each other out. These charges and weights help to define the properties of the elements. let's talk about elements for a minute. Elements are the simplest forms of matter. And as we already know, an atom is the smallest possible quantity of an element. Have you ever studied the periodic table of elements? The periodic table lists the elements in order by their atomic number. The atomic number represents the number of protons in every atom of an element. Let me show you some atomic numbers. Nitrogen's atomic number is 7. Therefore, each nitrogen atom has 7 protons in its nucleus. Boron's atomic number is 5. It has 5 protons. Look up the element sulfur. What is its atomic number and how many protons does it have? You got it. Sulfur's atomic number is 16, which means each atom of sulfur has 16 protons. Unlike protons, the number of neutrons within an atom of any element can vary somewhat. Now, these variations are called isotopes. Isotopes occur in nature at different rates. Some are common and some are rare. Hydrogen is an element that has naturally occurring isotopes. From the periodic table, we can tell that hydrogen has 1 proton. But in nature, there are 3 forms of hydrogen. Each has a different number of neutrons. The first isotope of hydrogen is called protium. It doesn't have any neutrons. The second isotope, deuterium, has only 1 neutron. The third isotope has 2 neutrons and is called tritium. As we discussed before, each proton and neutron have an atomic mass unit of 1. Because isotopes have varied numbers of neutrons, isotopes of the same element weigh differently. On the periodic table, there is an atomic mass number for each element. You may be wondering, if each element has isotopes that weigh different amounts, then how is an element's atomic mass determined? That's a very good question. The atomic mass of an element is figured as the weighted average of all its isotopes as they occur in nature. That's why the atomic mass number has decimal points. From the periodic table, we can determine the most common isotope of any element and how many neutrons this isotope has. Carbon, for example, has an atomic mass of 12.0111. Rounded to the nearest whole number, we get 12. Carbon-12 is the most common isotope of carbon. We also know from the atomic number that every carbon atom has 6 protons. We can determine by subtracting the total number of protons, 6, from the atomic mass number, 12, that carbon-12 has 6 neutrons. The number of protons and neutrons added together is called the mass number. It's basically counting the number of subatomic particles in the nucleus. Let's try one together. Let's look at aluminum. The atomic number is 13. Now, its atomic mass is 26.98. Round the atomic mass to the next whole number, which is 27. So, aluminum-27 is the most common isotope of aluminum. To figure out how many neutrons this isotope of aluminum has, subtract 13 from 27 to get 14. Aluminum-27 has 14 neutrons. Great job on the protons and neutrons. Now, let's work on electrons. An electrically neutral atom has equal numbers of protons and electrons. Their positive and negative charges cancel each other out. Remember those electron levels that Niels Bohr proposed? Well, those electrons orbit the nucleus at different levels depending upon how much energy they have. And each level can hold a certain number of electrons. The first level has 2, and the second and third hold 8 each. When the outer electron level is not full, it bonds with other atoms to help fill it. The tendency for an atom to attract or share electrons in this outer shell is called valence. That's why we say an atom's electron arrangement determines the element's chemical properties or the way they tend to bond with other elements. Atoms gaining electrons are negative ions. Atoms losing electrons are positive ions. Take common table salt, for example. Salt is a compound made of 2 elements, sodium and chlorine. When sodium gives up 1 electron, it becomes a positive ion. Chlorine, on the other hand, takes the electron, becoming a negative ion. Sodium and chlorine become oppositely charged ions that bond together to form sodium chloride, better known as table salt. This is known as ionic bonding because an electron is actually transferred from one atom to another. Compounds are more commonly formed through covalent bonding, or the sharing of electrons. Water is a good example. Two atoms of hydrogen share electrons with one atom of oxygen, stabilizing each atom's outer electron shell. The chemical properties of elements determine how they combine to form compounds. And compounds are just a more compound form of matter. So do you see just how much atoms matter? Amazing, isn't it? Well, now that we have recharged your knowledge of atoms, it's time for the quiz. Are you ready? Let's go!
Howdy, partners. You caught me just as I was heading off to the rodeo. I have a quick question for you first. Which of the following is not a subatomic particle? A. Electrons, B. Neutrons, C. Protons, or D. Neurons?
Ah, that's a tough one.
Wow, that looked like a wild ride, but I bet you hung on tight. Now just scribble down your guess and we can move on to a harder challenge.
Hey, practice my plate twirling while you were learning about atoms. Let's see what you know. Where in the atom might one find an electron? A, in the nucleus, B, in the electron section of the supermarket, C, in the electron cloud, or D, inside a neutron? Well, it looks like you've got the balance figured out. Write down how you did that for me. Thanks.
Get this next question right, or you'll find yourself walking the plank. Which two particles have the same atomic mass? A, protons and electrons, B, protons and neutrons, C, electrons and neutrons, or D, neutrons and positrons? All right, sailors, you saved yourselves this time. Good job. Write your answer down. We're sailing off to brighter shores.
We're zooming right through this lesson and you're doing great. Show off your atomic knowledge by answering this one. An atomic number represents the number of what in the atom's nucleus? A, protons, B, neutrons, C, electrons, or D, ions? You handled that just like us professional racers. Keep up the good work and don't forget to write your answers down.
DJ Ricky Wave coming to you straight down the science line from your favorite science station, KVQZ. Do I have some great hits to play for you? Check this new one out. The number of which subatomic particle can vary within an atom? A, isotope, B, neutron, C, ion, or D, proton? Alrighty, science fanatics, write down your answer and I'll catch you later on KVQZ, Science Radio. Radio for your head.
Well, students, after you answer my question, it's back to my magic bottle for some rest and deionization. Study hard. Protium, deuterium, and tritium are 3 what of hydrogen? A, ions, B, bonds, C, neutrons, or D, isotopes? You are so smart. Don't forget to write down your answers. Well, I'm going back in my bottle to rest now. Call me when you need me.
Okay, back to the drawing board for this one. Do your best and score one for the team. If the atomic mass of the element calcium is 40.08 and its atomic number is 20, which is the most common isotope of calcium? A, calcium 40, B, calcium 20, C, calcium 60, or D, calcium 20.08? I have never had a team who works so well. You're amazing. Write down your answers and it'll be time for a cool down.
Oh my, I cannot believe how great this show is. The atomic numbers are just fascinating. Someone is going to win an award for sure. Focus hard and it could be you. What is the name of an atom that loses or gains electrons? A, ion. B, charger. C, metal. D, atomizer. That was a wonderful presentation. Be sure to cast your vote for the best answer, and I'll see you at the next big science gala.
Quizithor is back. It is time to test your memory circuits again. If a neutral atom gains 2 electrons, its charge will be A, 0, B, positive 2, C, negative 2, D, neutral.
Will you look at that one?
Write down your answers. This is Quizithor. Goodbye.
Before I go on my spacewalk, let's see how you handle the depth of this question. True or false? An atom's electron arrangement determines the element's chemical properties, or the way the element tends to bond with other elements. Wow, you're as smart as physicist. Way to go, and I'll see you on my next orbit.
Well, how'd you do? Thanks for learning with us today. Stay tuned for a list of answers to our questions. So long, and I'll see you soon.
Okay, good job. Here come the answers.
Question 1. D. Humans began to theorize about atoms over 2,000 years ago. Question 2. False. Atoms cannot ever be divided into smaller pieces that still maintain original characteristics. Question 3. True. Air consists of gases which are made of atoms. Question 4. C. Dalton proposed the first modern atomic theory. Question 5. A. Dalton's atomic model did not include the travel of electrons and energy levels. Question 6. B. Thomson's model was called the plum pudding model. Question 7. D. Ernest Rutherford discovered the nucleus. Question 8. B. Niels Bohr proposed the notion that electrons circle the nucleus. Question 9. A. The current atomic model is called the wave model. Question 10. C. The nucleus is extremely small in relation to the electron orbit, like a bee in a football stadium. Question 11. D. A neuron is not a subatomic particle. Question 12. C. Electrons are found within the electron cloud. Question 13. B. Protons and neutrons have the same mass of 1 atomic mass unit. Question 14. A. An atom's atomic number represents the number of protons. Question 15. B. The number of neutrons can vary within an atom. Question 16. D. Protium, deuterium, and tritium are 3 naturally occurring isotopes of hydrogen. Question 17. A. Calcium-40 is the most common isotope. Question 18. A. An atom that loses or gains an electron is an ion. Question 19. C. When a neutral atom gains 2 electrons, its charge will be -2. Question 20. True. An atom's electron arrangement does determine its chemical properties.
Goodbye.
You want more? It's question 4.
Go, team, go!
It's back to my magic bottle for some...
Oops. Roll your boat gently down the stream. Merrily, merrily. Hey, oh, what is that? It's a freaky horsey.
View all 10 titles in the Science Video Quiz Series.
Atoms.
Clouds.
Classification.
Forces.
Motion.
Climate and seasons.
Fossils.
Mitosis.
Meiosis.
Water cycle.